This is into Physics 2010 question 22. And it says inside a storm cloud, water droplets move around and collide with each other. And here's a diagram of the water droplets. And a water droplet of mass 2 kilograms moving with a speed of 4 meters per second collides with a stationary water droplet of mass 1.2 kilograms. The two droplets join together to form a larger droplet. So they're joined together, therefore it's looking like a momentum question, and they're going to move off with the same velocity because they've joined together. Calculate the speed of this larger droplet after the collision. So let's go down, and again we'll start off by writing what we know. So the mass of the first droplet was, I need to remind myself, 2 grams. Did I say kilograms? It's 2 grams. We change that into kilograms. The mass, but we divide it by 1,000, so it will be 2 times 10 to the minus 3 kilograms, and it has a velocity. We'll call this mass 1. Is the velocity 1 is, again remind myself, 4 meters per second, and then we've got a second droplet which is a mass of 1.2 grams, so the mass 2 is equal to 1.2 times 10 to the minus 3 kilograms, and that velocity is 0 meters per second. And then they're going to join together, and we want to work out the final velocity. So we know that momentum before is equal to the momentum after. And to calculate the momentum before, we've got m1 multiplied by v1 added to m2 multiplied by v2, which is going to be equal to the momentum after. Now they join together, so mass 1 and mass 2 join together, and they've got a new velocity which we're going to call v3. So let's put in the numbers. We've got 2 times 10 to the negative 3 multiplied by 4 plus 1.2 times 10 to the minus 3 multiplied by 0 is equal to 2 times 10 to the minus 3 plus 1.2 times 10 to the minus 3 is 3.2 times 10 to the minus 3 multiplied by v3. Now, I know that that just goes to 0. I've got 2 to the negative 3 times 4. So I've got 8 times 10 to the negative 3 equals 3.2 times 10 to the negative 3 v3. If I make v3 the subject of the formula, it becomes 8 times 10 to the negative 3 divided by 3.2 to the negative 3. So the final velocity is 2.5 meters per second. The next question asks, another water droplet within the cloud is falling with a constant speed. So already alarm bell should be ringing in your head. Constant speed. What does that tell you about the forces acting on an object if it's moving with a constant speed? Draw a diagram showing the forces acting on this droplet. Name these forces and show their direction. Okay, so what is the question asking you to do? It's asking you to name the forces and show its direction. So we're going to have a droplet. And it's going to have a weight, which is acting downwards. And if that was the only force acting on the droplet, it would be an unbalanced force, and it would accelerate downwards and increase acceleration for forever. But it's going at a constant speed, so there must be a force here, and that's just caused by air resistance. And these forces must be exactly the same size because the forces are balanced, because it's travelling with a constant speed. So let's just check the question again. Another water droplet within the cloud is falling with a constant speed. Draw a diagram showing the forces acting on this droplet. Name them and show their direction. So we don't need to calculate any size or magnitude, we just need to name them and show their direction. The third question says, the motion of water droplets in the cloud causes flashes of lightning. One lightning flash transfers 1650 C of charge, so we now know it's 1650 coulombs of charge in 0.15 s, so it's a time of 0.15 seconds. Calculate the electric current produced by this flash. So let's just start by writing down what we know. I'm on to question C. We know that the charge is 1650 coulombs. We know that the time is 0.15 seconds, and we're trying to work out the electric current, which hopefully you remember is measured in units of amps. Now the formula is Q equals I multiplied by T, so I is equal to Q divided by T. Then just put in our numbers. It's 1650 divided by 0.15. 1650 divided by 0.15 would give a current of 11,000 amps. And the last question says, why does an observer standing 3 kilometers from a thundercloud see a lightning flash before he hears the thunder? Well, lightning is just light and thunder is sound, and just your general knowledge from Unit 3 of Physics should tell you that light travels faster than sound. That's all you need to write. Light travels faster than sound. That's why when I see a firework go off, I admire the beautiful colours, and then I know I've got a second, maybe a second and a half before I'm going to hear the explosion of the fireworks, so I can cover my ears. So light travels faster than sound.